Welcome to ClickMyProject.com.
Let me discuss about the project Cognitive and Energy Harvesting Based D2D Communication in Cellular Networks, Stochastic Geometric Modeling and Analysis. Let me discuss about the abstract of the project. The amount of data traffic in cellular networks has been increasing dramatically in the past few decades. To cope with traffic increase, heterogeneous cellular network has been introduced to improve the network performance by offloading traffic to access points with better link quality. The increase of energy consumption directly increases the greenhouse gas emissions, which threatens the environment. Radio frequency, energy transfer, and harvesting techniques have recently become alternative methods to power the next generation wireless networks. The D2D communication can enhance cell coverage and throughput and also reduce transmit power. The study investigates cognitive and energy harvesting based device to device communication underlying cellular networks. Energy harvesting based device to device communication for cellular network are proposed. For implementing this approach, spectrum access policies are proposed at both uplink and downlink. A random spectrum access policy, prioritized spectrum access policy are implemented. In RSA, cellular user can select any of the available channel, which includes the D2D channels. Whereas in the case of PSA, cellular user can select D2D channel only when the remaining channels are occupied conditions. The SINR outage probability requirements are estimated under both spectrum access policies, that is RSA and PSA. Among RSA and PSA policy provides better performance to the device-to-device users. For D2D users, provides better performance when using an uplink channel compared with the downlink channel. Let me discuss about the flow diagram for our process. Initially, deploy the cellular user and device-to-device user randomly, and the communication link between the device-to-device transmitter and also device-to-device receiver are performed. Next, the channels are allocated for all cellular user and also device-to-device user. In this channel model, an uplink channel or downlink channel used for cellular communication. In this workup, it is considered both cases when the device-to-device transmission can take place either in one of the uplink channels or one of the downlink channels. There is no intra-cell interference, assuming that each BS serves no more than one user in each channel. Next, in the spectrum access model for cellular transmission, it is considered two spectrum access policies, namely random spectrum access policy RSA and prioritized spectrum access policy PSA, that define how the spectrum is assigned for downlink and uplink transmission to serve the cellular users. In RSA, in each cell any channel including channel CD which is used for device-to-device transmission. Next, it is aims at quantifying the performance of both device-to-device and D2D and cellular communication in terms of transmission probability. For D2D users, that is the probability that there is a channel available for transmission and the amount of harvested energy is sufficient for device-to-device transmission, and SINR outage probability of both D2D and cellular users. These results should be then valid for any generic user. We derive the spectrum access probabilities for the cellular communications. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. Here the cellular user, device-to-device transmitter and device-to-device receivers are deployed randomly, and the potential D2D links are performed between device-to-device transmitter and also D2D receiver, and the RSA and PSA algorithms are performed for allocating the channel spectrum allocation process. This process will take some time for executing. This is the representation of base station deployment. We deploy the base station randomly. This is the representation of cellular user deployment. These are deployed randomly. And this is the device to device transmitter deployment. And this is the device to device receiver deployment. This orange node represents the device to device receiver. And this is the potential device to device links between device to device transmitter and also device to device receiver. And this is the potential device D2D links with the radius representation. Here the circle having radius between device D2D transmitter, and this is the transmission probability point for a generic D2D transmitter versus the intensity of BSS. And this is the transmission probability for a generic D2D transmitter versus the intensity of BSS. Here the graph performed for downlink RSA and downlink PSA, as well as uplink RSA and also uplink PSA, and the simulated results. And this is the transmission probability point for transmission probability, free channel probability, sufficient energy probability, and proposed approach. Obtain the values. This is the transmission probability point for transmission probability, free channel probability, sufficient energy probability, and also proposed approach. This is the SINR outage probability for downlink RSA, downlink PSA, uplink RSA, uplink PSA, and proposed approach. The transmission probability point, downlink RSA, downlink PSA, uplink RSA, uplink PSA, and the proposed approach. This is the SINR outage probability for D2D users. And this is the SINR outage probability for device to device transmitter versus the number of available channels. These are performed for RSA and PSA for both uplink and downlink cases. The simulated results are plotted. This is the SINR outage probability for device to device transmission versus the number of available channels. These are performed for both RS and PSA algorithm for both the cases of downlink and uplink cases. Also, the proposed approaches are implemented in similar way. This is the overall outage probability for device downlink RSA, PSA, uplink RSA, and uplink PSA versus proposed approach. RF energy harvesting based D2D communication implemented for both downlink and uplink cellular network. The PSA policy outperforms the RSA policy. At the same time, uplink channel for preferred to downlink channel when the cellular network with low density BSS. Thank you.